So picture this. You put an animal in a really uncomfortable, painful situation, and you give it a wide open, super obvious path to escape. You'd expect it to run, right? I mean, that's just basic survival instinct. But what happens when it just sits there, taking the pain, making absolutely no effort to leave? Why on earth would some dogs passively accept a shock they could easily escape? Well, let's dive into this, because today we're unpacking one of the most famous and honestly most baffling behavioral anomalies ever recorded in experimental psychology. See, before the research we're talking about today, the scientific community just took it as a given that an animal would always naturally try to escape something aversive. But researchers kept hitting this bizarre wall in their labs. As the authors of our study noted, they passively accept shock and fail to make escape movements. This completely defied all the existing learning theories of the time. I mean, why would an organism literally just give up?
Welcome to this explainer on an absolute paradigm shift in behavioral science. We are looking at the landmark 1967 paper, Failure to Escape Traumatic Shock, by Martin E.P. Seligman and Steven F. Maier. This single publication fundamentally altered how we understand motivation, trauma, and learning. It introduced a concept that you have probably heard of, learned helplessness.
Our agenda for today is pretty straightforward. 1. The mystery of giving up. 2. Experiment 1, testing escapability. 3. Experiment 2, preventing helplessness. And finally, 4, the learned helplessness theory. Okay, Section 1, the mystery of giving up, the anomaly in behavioral research. To really set the stage here, we need to understand what prompted this whole investigation in the first place. In prior studies, dogs were exposed to inescapable shock while they were restrained in a harness. Later on, they were put into a two-way shuttle box. Basically, they could just hop over a tiny barrier to escape the shock entirely. But they exhibited the strangest behavior. Initially, yeah, they showed normal reactivity, running around, barking, desperately trying to get away. But eventually, they just settled into this eerie, passive acceptance. They completely failed to make escape movements. And the wildest part was that even if a dog accidentally jumped the barrier and escaped once, it didn't click. They didn't learn from it. The next time, they'd just revert right back to passively taking the shock. Seligman and Maier looked at this anomaly and came up with a genuinely brilliant hypothesis. They suspected that it actually wasn't the physical shock itself that was breaking the dog's will to escape. Instead, it was the psychological experience of having zero control. Their hypothesis was that the degree of control over the shock, meaning whether their physical actions actually mattered, was the true cause of this interference effect. Which brings us to Section 2, Experiment 1, testing escapability, and the yoked control design. So, how do you scientifically isolate control as a variable? Well, you use something called a yoked control design. They divided the dogs into groups. In the harness phase, the escape group could press a panel with their head to immediately turn off the shock. They had full control. But the yoked control group was paired or yoked to that escape group. For them, pressing the panel did absolutely nothing. Their shock only turned off when their paired dog and the escape group pressed its panel. Think about that for a second. Both groups are getting the exact same number of shocks at the exact same intensity for the exact same duration. Physically, their experiences are identical, but psychologically, they're worlds apart. Fast forward 24 hours. They take these dogs and put them into the shuttle box, where jumping that little barrier easily escapes the shock. The escape group, the ones who previously had control, figured it out fast. They took about 27 seconds to jump, and literally 0% of them failed to learn the escape route. They acted exactly like a normal control group of dogs who had never been shocked before in their lives. But the yoked control group? Completely different story. Their average time to jump skyrocketed to over 48 seconds. And a massive 75% of them failed to escape on 9 or more of their 10 trials. I really want to pause and emphasize this one specific number, 7.25. Out of 10 chances to simply step over a barrier and stop the pain, the dogs in the yoked control group failed an average of 7.25 times. This staggering number was the definitive proof for their hypothesis. The prior lack of control, that lived experience of inescapability, directly interfered with their ability to even initiate an escape response later on, even when escape was literally right in front of them. And looking back at the data from the initial publication, there's a fascinating detail about that first harness phase. The yoked dogs actually did start out pressing the panels, desperately trying to find a way out just like the others. But they typically just ceased panel pressing altogether after about 30 trials. They had quite literally learned that their actions were utterly useless.
Moving right along to Section 3, Experiment 2, Preventing Helplessness, and the Immunization Effect. Okay, so if a lack of control teaches you to be helpless, is the opposite true? Seligman and Maier asked, if inescapable shock causes helplessness, can prior experience with escapable shock prevent it? To test this out, they set up a pre-escape group. Step 1. These dogs were put into the shuttle box first, where they successfully learned to escape by jumping the barrier. Step 2. The very next day, they were strapped into the harness and given that inescapable yoked shock. No control whatsoever. Step 3. On the third day, they went back to the shuttle box. The big question was, would the trauma of having no control in Step 2 erase the agency they had just learned in Step 1? The data tracking their latency, which is just how long it took the dogs to jump, reveals something pretty incredible. The pre-escape group maintained really low latency times even after enduring the inescapable shock. They navigated the shuttle box quickly and efficiently. That inescapable shock in the harness, it didn't break them. And when you track the mean number of failures, the contrast is stark. The group with absolutely no prior escape experience suffered massive interference when subjected to inescapable shock. They failed constantly. But that pre-escape group was largely protected. They successfully jumped the barrier over and over. They had essentially been immunized against learned helplessness. There's also this really fascinating behavioral detail noted by the researchers during the experiment. While strapped into the harness during the inescapable shock phase, the dogs who had prior escapable experience actually showed much more energetic behavior. They fought harder. Because they had already learned that their actions could matter, they didn't just passively accept the pain when they were trapped, they kept trying to find a way out. Section 4. The Learned Helplessness Theory. Redefining Learning. The implications of all these experiments really forced psychologists to fundamentally broaden their understanding of how learning actually works. Seligman and Maier defined learned helplessness as learning that reinforcement, which in this case is the termination of the shock, is completely independent of responding. Let that sink in. It's not a loss of physical energy. It's a cognitive realization. The animal learns a distinct relationship. Nothing I do matters. And once that expectation sets in, it drastically reduces the incentive to even bother trying to respond in the future. Now, the researchers were meticulously thorough in ruling out alternative explanations. They proved it wasn't just physical adaptation to the shock, because the helplessness still happened even when they cranked up the voltage. It wasn't that the dogs had accidentally learned a competing physical movement, like, just sitting still. And we know this for sure thanks to a really wild detail from the paper. They proved it using curare paralysis experiments. They actually paralyzed dogs with a drug called curare during the inescapable shock, meaning the dogs couldn't move a single muscle if they tried. Yet, later on in the shuttle box, once the drug wore off, those dogs still exhibited learned helplessness. The paralysis proved, without a doubt, that the phenomenon was happening in the brain as a cognitive expectation, not in the muscles. Ultimately, this paper proposed a massive update to learning theory. Up until then, behavioral psychology stressed two main operations. You had contiguity, which is learning that two events are paired together, and you had non-contiguity, which is learning to unpair them, also known as extinction. But Seligman and Maier argued for a third, equally powerful operation: independence. Organisms can actively learn that two events are entirely 100% disconnected. The authors ended their 1967 paper by looking forward, asking a question that honestly changed psychology forever. Does learning that responding is futile in aversive situations transfer to appetitive or reward situations? In simpler terms, if life teaches you that you have absolutely no control over the bad things, does that learned helplessness bleed over? Does it stop you from even trying to achieve the good things? It is a deeply provocative thought, one that paved the way for decades of crucial research into human depression, motivation, and resilience. Thanks so much for joining me for this explainer, and I really hope this leaves you with a lot to think about regarding the profound everyday power of agency.